Welcome to Fabric Monday. This week we'll talk about maintenance optimization for multiple lake houses. We have a workspace called Malta Fabric Demo, and inside this workspace we have 3 lake houses. So we'll organize the same script that we built last week to execute the maintenance work, the vacuum and optimize for all the 3 lake houses at once. Here you can see the same script that we built last week. This is absolutely the same script linked to the Malta Lake, which is one of the lake houses, not all the 3. So we have some challenge to get the information from the 3 lake houses. The first thing is that we need to list the lake houses. Let's make an example. This code is a simple code that will list the lake houses available. I'm using Spark Catalog List Database. Then I get the list and get only the name of the lake house. I don't need anything else from this. I get only the name of the lake house and show the list. This is only a simple code. Only a simple code for us to see that it's possible to list the lake house. But what lake house am I listing? Am I listing all the lake houses in the Power BI portal? No. I'm listing only the lake house on this workspace. This is limited to the workspace level. So I can make the maintenance at workspace level for all the lake house in the same workspace. So let's list the lake houses available. We got a list of the 3 lake houses available: Malta Lake, Data Flow Staging Lake House, and Lake Bridge. All the 3 lake houses available. That's great. And this is only an example of what we can do, because in real scenarios we would not handle the Data Flow Staging Lake House. After I got a list of the lake house, I need to be sure that I can list the tables inside each lake house. Usually I could list the tables inside the lake house which is linked to the notebook, which is the full lake house. But now I would like to list the tables inside 3 different lake houses which are not linked to the notebook. I haven't even included this lake house here, and I will not include this lake house here to show that this is not needed. How I will list the tables? I use the variable that we got from the previous example, lake house list, and make a for each lake house. I will execute the show tables in lake. Show tables in lake and display the result. Let's take a look. So we see the tables from Malta Lake, we see the tables from Lake Bridge. The 3rd lake house has no tables available, no data available, no tables available. Okay, but the result I used the display. This is a data frame. But what I need is just the name of the table. I need after having the name of the lake house, I need the name of the tables. So how do we solve this? Simple. Let's improve this code. I'll get the result, tables, convert to pandas and get only the table name, converting the table name to list. Then I have an array. I have my list of table names for each lake house. Now that we have seen that we can get the list of lake houses, and we can get the list of tables on each lake house, what we need to do? We need to change our main maintenance code. This main maintenance code is making a loop on the list of tables of a lake house. Now we need to make a loop through different lake houses. So we have one additional loop to be done. Besides that, we have the optimize and vacuum, the maintenance that we would like to work. The optimize will work well if I just add the name of the lake house in front of the table name. Lakehouse name dot table name. But the vacuum, I need to change a bit the syntax. Let's take a look how the vacuum syntax will need to change. Our code is using this vacuum syntax. It uses a path, tables, dash, and the name of the folder where the table is, between single quotes. We can't do this anymore to use multiple lake house. To use multiple lake house, we need to change the syntax, but vacuum supports a different syntax. So we need to change the syntax to use the name of the lake house dot the name of the table. So in this sample script, we will change the syntax of the vacuum. This will enable us to execute the vacuum for multiple lake houses. Once we know what we need to change, let's see how will be the new code. I have new functions now. On this new code, I have new functions. The previous existing function clean tables continues here with different parameters, the lakehouse name and the table name. The optimize, the vacuum, and the print were fixed to use these parameters, and this vacuum syntax was changed. That's great. And now I have a new function called clean lakehouse. The purpose of this function is to receive the name of one lakehouse and execute the cleaning for one lakehouse. Receiving the name of one lakehouse, it needs to retrieve the list of tables from this lakehouse and execute the cleaning for each table. So, having the name of the lakehouse, we execute the show tables in lake, convert to pandas to extract only the table names, and for each table we call clean table. So clean lakehouse, show tables in lake, convert to pandas, extracts the table name and call clean table. So clean lakehouse calls clean tables. Then we have another function called list lakes. The purpose of this function is to retrieve a list of the lake houses. So I use the Spark catalog in this database, use the for to extract only the name of the lake house, and now we have a return. I return the list of the lake houses. The main code joins all these functions together. What the main code does? It starts with the configuration, which we already talked last week. Then I get the list of lake houses, calling the function list lakes, and for each lake I call the function clean lake house, which calls the function clean tables for each table on the lake house. And in this way our code will execute optimize and vacuum for all the tables in all the Lakehouse on this workspace. The first code blocks are not needed. I used them only for demonstration of the pieces of code we would use. I don't need these first code blocks. This is the main code block that we need, and I can execute it. Now with the execution completed, we can just schedule this notebook exactly as we did last week. I'll not complete the process, we already saw this on the previous video. Using this example in PySpark, we can make the maintenance, optimize and vacuum for all the Lakehouse in a single workspace. See you on next Fabric Monday.